let's see. So not a ton of formulas. And again, you could just keep adding formulas. You could bring all the other formula sheets. You just turn them in. Or you can just bring the one just for the probability stuff. So what was the probability A or B? What was OR basically? What does it basically mean? What operation does OR add? OR basically means add. So that's a big thing to get from this. So if I add A and stuff and B stuff together, I might have counted some things twice. That's why I say basically add. It basically means add. It might have a little adjustment. I like it. And then we're going to do this a little out of order from what we did, but what's the and basically mean? Multiply. Yes. And basically means multiply. It makes sense because OR is the nice bouncer. More people should get in, so it's adding stuff. AND's the mean bouncer. Less people should get in. And when you multiply numbers less than 1 greater than 0, they get smaller. So this is going to be either this or that. Either way. So let me explain, if anybody has any trouble, why there's two ways to do this. Remember when we did the picking people out of the haunted house? If probably get an independent and then a Democrat, for example, when I'm letting one go, should it be different than from the probably get a Democrat and then an independent? It should not be different. They're still the same people, aren't they? So that's why it doesn't matter which one you do first, which one you do second. Maybe. And then one last one, of course. So if I know that B happened, it's going to be out of that. And then if B happened, the only way A could also happen is if it's in B. So just remember, couple things. We did a lot of problems before we knew these formulas. In fact, we had problems and then we created the formulas based on what the shit we did, right? So a lot of the problems on the quiz you're actually not going to need to use any formulas for. In fact, using formulas often is the and one that gets people in trouble. Using the formula is going to make it a lot harder than it needs to be. There will be a problem, at least one, like on the practice quiz, where you have to use the formulas because they don't give you all the counts, right? Probability is based off of counting stuff. So if I don't give you the stuff to count, oh shit. That's where the math comes in and says, I got you. All right, maybe. Anything else you think should be up there? I'm excited because I don't think there should be, so you never know. I could be wrong. Yes, no, maybe. Any other formulas that should be on there? Or was that just a random sound? Okay. All right, cool. That's it. That's all that could be on your formula sheet. You can bring the other formulas with you. I don't know why you would. Just in case you want to bank one big ass formula sheet for the whole semester, that's great. Okay. Okay, maybe. You guys doing all right? I know it is 7 a.m., so that's part of it. I understand. I live off caffeine.
Can you explain a little bit about like the independent and mutually
Oh, sure.
exclusive
Okay,
part?
I like it. Let's see. So I want to make sure everybody's got this stuff going on. Some people just came in. So I'm going to leave this here. Let's see if anybody gets themselves in trouble. Everything in blue right now cannot be on your formula sheet. Yeah. Okay. So there are some problems in the homework. I don't know if we did one of these, if somebody asked about this. There's like the 40s. There's only a few problems in section 3.2 maybe? I can't remember. And people gloss right over the first sentence. So it could have a problem like, for example, W and L are independent events. Where's the N? There it is. Events. And then it kind of keeps going. And a lot of people just, you're like, I'm in math class. Those are words. What does that matter? Let me get to some numbers and do some shit. But that's the most important part of that problem. Whatever the hell else they say next, you got to stop. What can I write because of that? There's two things I could write just from what this is saying. What does it mean? And this is your question. You're like, I don't know. What does it mean for W and L to be independent? Right? If they don't care about each other. Yeah. If L happens, for example. If L happens. So given that L happened, will W give a shit? No. So it should stay the same as what it was. That's it. It's almost too beautiful that that's what it means. But nobody seems to agree with me ever. But I don't know. This is probably, anyway, you don't have to know all this. But it's probably one of the things that I don't know how to explain better. And it's just driving me crazy. It's that simple. If they are to be independent, you must check how they affect each other. If I say, are they independent? You must check a probability that deals with how do they affect each other. And the only probability that shows that at all is this one. So of course you got to check that, given that L happened. If the probability W stays the same, ooh, that's my fifth puberty, then it's independent. So what about the other way? What if W happens? If they're independent, does L give a shit? No. So there's a problem that says, I think it's J and K are independent. So you can write those down. And then the question they ask is easy. If you don't write those down, question's impossible. You'll have a question mark. How do I figure this out, Jeff? Well, don't skip the first sentence. I like it. Has everybody got the formulas now? Yes? Okay. So what about mutually exclusive?
You got to equal 0?
Be more specific. So if I know that A and B are mutually exclusive, what does mutually exclusive mean? What is exclusive? When I say the word, especially if I say it like this, exclusive. What does exclusive mean? What do you think when I say exclusive?
Only one.
Sing. Only, okay.
Unique.
Give me a place that would be described as exclusive.
A nightclub.
Sure, yeah. What does that mean? They'll only let
certain
people in. I like it. Right? Exclusive, it excludes something. Right? Are you with me? Okay, I like it. Mutually exclusive means they both exclude each other. You can't be over here, but you can't be over here. Right? So I used to do dog and cat, but I don't know if you guys know about the cartoon Cat Dog. All right. So you guys don't know, that's fine. It's an older one. It's back from, well, not really from my time, but so rock, there's a rock, right? If I'm holding a rock, can I at the same time, if I'm only holding one thing and it's a rock, can I be holding ice cream? Can this rock be ice cream? I don't care as much as you want it to be. You're stuck on a desert island. Come on, rock, just become ice cream. It's not going to. Right? You can lick it if you want to. That's really gross. But it's not going to be ice cream. Right? So that's what it's mutual. So rocks cannot also be ice cream. So if A and B are mutually exclusive, what's the probability that something is both? 0. So if I was holding a small mammal, could I be holding a cat? You can do this. Think before you answer. If I was holding a small mammal, could I be holding a cat?
Yes.
Because cats are mammals. Some mammals are cats. Are you with me? So those would not be mutually exclusive. Because you could be both. Okay, I like it. So mutually exclusive means you can't be both. Bam. So if you see a problem where the first sentence says this and this are mutually exclusive, you stop and you write this down. And then whatever question they ask you, you can use this to help you answer it. Okay, maybe. All right. Okay, I like it. Is that cool? All right. So we can look at everybody's got a copy of the practice quiz now, right? It was on the back side of that probability worksheet. Everybody's got that sucker. Any questions from this before I give you guys the answer key? Do we have a chance to do it yet? Of course, your main priority should be homework. I'm an optimistic fool, so this means that it went really great. Everybody understood it. It was fantastic.
I think the second question was kind of tricky.
You want to know the
For
candy
me?
bars?
Yeah.
Okay.
So it should be like 3 multiplications.
Yes.
Okay.
So
So
the
you don't
idea.
put two together, like for example, TTS. You don't put like those two T's.
So let's see that one. Let's see. So in that problem.
Can we do one with replacement, one without?
Sure.
Okay.
It's what I do. So in number 2, what's the probability I get a Twix? Let's just do that real quick. Let's probably get a Twix. 7. That's a good start.
And there's 13 total.
Yeah, and there's 13 total, so 7 out of 13. So whatever your answer to a probability question is, it cannot be greater than 1. If you get something bigger than 1 and you can't see why that's wrong, cross through it and just say, I know it shouldn't be bigger than 1. You'll get an extra point for that. If you just leave the answers, 128% chance. Shit, this is bad. That's what the math said. No, you did something wrong. You just won't see what it is. What's the probability I get, what else was there? Snickers? Let's probably get a Snickers.
1 out of 13.
What is it?
1?
5 out of 13.
Oh yeah, sorry, 5.
And they'll probably get a Butterfinger.
1.
1 out of 13. I like it. Right? I didn't ask for those, but if I were you, I might do that for myself real quick. And now the questions become not too bad. Let's do this first one. Let's do 1A and then 2A there. Because that's the with and without replacement. So this is with replacement. Twickers. I do that every time. I can't handle it. So Twix, and Snickers. Not 6 and Twickers. Tweakers. Don't eat that candy. So what's probably gonna Twix, Snickers. So what's probably the first one? I'm doing it with replacement. So I pick it. I'm like, I don't want a Twix. I don't want a Twix. All right, so I just.
13.
So yeah, probably the first one's. This is 5 out of 13, and then a Twix. So there's an there's like a hidden and in there, right? I get a Twix and then a Twix.
A 7, no?
Sorry.
D is
Oh, 7. Thank you. And then another Twix and then a Snickers. So what's probably get then another Twix?
7 out of
7 out of
13.
13. And now it's probably gonna and then I put that back in. Now this is gonna be 5 out of 13. I like it. And then whatever the hell that is. Now if I would have picked 18 candy bars. I'm looking for the Butterfinger, and for some reason I can't look in this bag, right? And if Twix, Snickers, Twix, Snickers, Twix, Snickers, and then Butterfinger finally, right? I would just have, whatever it's 18 things in a row here. Do you guys see that? And doesn't give a shit. And means multiply. How much? As much as you pick. I like it. So whatever the hell that is. Well, how's this going to change when I do it without replacement? So the first one is a Twix. It's still 7 out of 13, and then I eat it. And then I reach back in. Let's probably get another Twix.
7 on.
Careful.
6 out of.
Oh.
I just ate a Twix.
Oh.
So there's only 6 Twix left
Out of
out of 12.
We're gonna change the
5.
Say again?
We're gonna change the.
Say it again.
We're gonna change the one on the last one. Or number 5.
All right, this first problem was with replacement. So I would pick it, and then I put it back. And then I pick it, and then I put it back. So of course nothing changes up here because I keep putting it back. Here's without replacement. I pick it, I eat it. I pick it, I eat it. So how many candy bars are left?
5
For this
out
third
of
one.
11.
11, but there's still
5.
all 5 Snickers because I didn't eat any Snickers. I ate Twix. You guys get that? It's the same idea. It doesn't matter how many picks I do. You just keep on multiplying. Going slightly insane. Just keep on multiplying. Now the interesting one of that is the second one with the Butterfinger twice.
Or the C, you know?
Huh?
The C one that is all.
Who
oh,
cares?
No,
That
they're all
one.
Snickers.
Well, that
yeah,
one.
Yeah, the Butterfinger
Yeah,
that has
5,
only
4,
one,
3.
So
Right.
it'll be like 0.
13, 12, 11. So the top and bottom will both change for that, just like the Twix did. But the second one's interesting for the Butterfinger Twix
only one.
Butterfinger.
Yeah.
I don't know,
So
if you haven't tried this, you have no idea what I'm talking about. But if there's only one Butterfinger in the whole thing, what's probably without replacement, I get a couple Butterfingers. 0.
Yeah.
Can't do it. But if it's with replacement, it's fine. I don't eat it. I put it back in.
It's much better.
So just to make sure you guys get what I'm saying, if I would have picked 5 bars, 5 candy bars, let's probably get nothing but Snickers with replacement.
Would be 5 times 5 out of 13.
No. 5 out of 13. And then it would be times 5 out of 13 times 5 out of 13,
Yeah,
right?
5 times.
So you can do 5 out of 13 to the 5th power, because they're all the same. You guys see that? Because it would be 5 out of 13 times 5 out of 13 times 5 out of 13. So it would be that to the 5th power. That makes sense. Got 5 of the same candy bar. If I did it without, now here's what I think. What if I did that without replacement? 5 Snickers.
5 out of 13. Then
5 out of 13 chance for the first one, I eat it.
4 out of
4 out of 13, I eat it. 12, thank you.
Yeah. 3
3 out of 11, I eat it.
2 out of 10 and 1 out of 9.
I like it. And then you just multiply it. Yeah, it would be. So, let's see. So if I look at Butterfinger, Twix, Butterfinger, if I do it with replacement, that would be 1 out of 13 chance for the Butterfinger. Put it back in. 7 out of 13. Put it back in. 1 out of 13, and then back. If I do it without replacement, 1 out of 13 for that Butterfinger. What's the probably the Twix now? 7 out of 12. And now what's probably that other Butterfinger? Say again, sorry. I mean, you know, going ahead of time, you know that it's supposed to be 0 chance. How can you get 2 Butterfingers when there's 1 and you're not putting them back in? So sure enough, the math goes, oh shit, you're right. It is 0. So let me give you guys, I'll give you guys the answer key. There's something on the other side we're going to do in a minute, but the answer key is the one with all the red writing. Red writing. Thought I would spare you from my beautiful handwriting, so I did this on the computer. Yeah. So which one, sorry? 1B. Okay. No, the order doesn't matter. I'm not. How do you mean though? Yeah, sure. I just added the what did I do? I added the females first and then the Fords, but you can add the Fords first and then the females first. It doesn't matter. Yeah, as long as you get both groups in there. So please, again, if you did not try the practice quiz out for yourself, do not now look at this and just agree with it, right? I think I told you that about the last answer Kate gave you. That builds false confidence. Yes?
Sorry, is there a chance that you're gonna ask us to interpret, like B, A and B example? What does that mean? You know?
Oh, I see.
Like, or given.
Yeah, there's
Like,
a chance.
I
It was
think
in the
that might be
homework,
like-
sure.
Yeah.
There's a chance. Whatever was in the homework could be on there too. Yeah. I normally go the other way with that, so I give you a statement, then you have to write the symbols for it. And that was in the homework also, right? So I love students who are like, you gave us a test and a quiz without that. We never did it. Oh my God. We did this one on homework, this one. Yeah. Homework is important. So I give you guys a little bit. If I don't see any questions, we're gonna go into chapter 4, or continue with chapter 4 that we started. Yeah. Monica, no. Alessandra? Alessandra. Anybody tried out the tutoring center yet? Yes? Is it good? They helping out? Okay. Again, it's free. Very high chance of surviving compared to Craigslist, for example. Right? Any of you guys ever try to go see your professor in this office where he always is before the class? Like, no, I get enough of that guy. Jeez. Man, he was a rough crowd. Shit. Alright. Alright. Yes. Yes.
Because I was a kid, so I was kind of confused on what
Were you so you weren't here earlier, I guess? When we did that? No? Alright. So one more time. And don't forget, I think I just said this. Remember, I put all the lectures up on YouTube. Right? You can put me at like 0.5 speed, or 1.5, and just play around with it. Or you can actually, try to learn more shit. So again, if to check, how do I test A and B for? Let me say it like this. This is a little bit different than what I said earlier. It's still the same idea. How do I test those for independence? What do I need to check? I need to compare something. Yes. Probability of A.
And B, if it equals
So if I
A
gotta-
or B.
Compare this with what?
B, A, and B.
No. Not the PA and B. No. What do I compare that to? What's the only probability that tells me how they affect each other?
The given.
The given. So I compare it to. Please let this make sense. If B happens, does the probability of A stay the same? If so, they're independent. Right? If the probability of A stays the same, even if somebody tells me B happened, then they're independent. If that's not true, they're dependent. If this isn't true, then the probability of A depends on if B happened or not. That's why we call it dependent. I know math people have trouble with words sometimes, so we name things really weird things. Sometimes we do really well, and this is one of the best places. Maybe. So let me say this. I think I said this before. When I ask you a question about independence, the more words you write, the more wrong you probably are. It's a very mathematical idea. It is this. Compare this number with that number and then tell me the answer. You can say dependent because they're different or independent because they're the same. That's probably the most words you want. If you start saying, well, no, it's dependent because this guy, and then you can have this. No, it's wrong. It's wrong. You cannot reason it out like that. It's a mathematical idea. Maybe. I call this my hopeful Tai Chi. So hopeful. And so you've got the weekend coming. If the first test was bad for you and you didn't do the homework for it, try an experiment. Do the chapter 3 homework and then see if that has an effect on how you do on the quiz. And if it doesn't have any effect, you can come see me and say, I've done my testing and you're completely full of shit, Jeff. And then we'll talk about it. But try it. Just give it a try. Just, go crazy. Okay. All right. This guy won't shut up about the homework, I know. All right. Anything else about probability before we move on? Is that all right? You guys all right? Everybody did the last problem okay? I thought that's normally the number 3, for example, and number 4. Those are the two kind of hardest ones normally. You see how I was nice to myself in number 3? I defined dislike was D and like was L. You don't have to, but that's not a bad idea. And number 4 is the one where you definitely have to use straight up formulas because I don't give you anything to count.
What do you mean is equal?
Where are we at?
What do you mean is equal?
Is equal. I mean, where? What?
Not equal.
Not equal.
Yeah.
Where are we talking?
4.
4. Oh. Again, in order for A and B to be independent, what must be true about the probability of A and the probability of A given B? If they're independent, A shouldn't give a shit if B happens. So the probability of A should be equal to the probability of A given B. But here, what happens? The probability of A is 0.8. If I know that B happened, what happens to the probability of A on number 4? It goes up. For some reason, if I know B happens, the probability of A goes up for some reason. Right? It increases the chances. So sort of like the probability somebody, this is so morbid, I know, dies for some, but if you have a condition, maybe the probability die goes up a little bit. Do you see what I'm saying? It's that idea. That's the idea of dependence. Since those aren't equal, I know they're not independent. I like it. Okay. Okay. So let's get back into 4. Anybody need the handout from chapter 4? This was something we worked on last time. One side of this is a workout example, and the other side is what we did in class. Oh shit. Oh, is there more people that need it? You must have this. No. No? Shit. Oh well. Let me see if I have another one maybe. Well, sure. Well, shit. No, you can have this one. Just try to do the problem yourself, but now you see the answers. Okay. So we actually got through 401, 4.2. So let's do a very quick little review of what we did on. I'm not going to redo this because it's all up on the YouTubes. So we have some new formulas. And hopefully it made sense. If I just give you a list of data, I'm going to calculate the average and the standard deviation like we did in chapter 2. But if I give you data like this, right? If I give you an x, p of x table, this really is just a relative frequency table, to be honest. But now we're calling them probabilities because that's what they are. To find the mean, I would do this. Multiply each value by its weight, plus the value times the weight, plus the value times the weight. That's how you calculate your average in a class like mine, because the tests are like 50-something%, right? So you would take your test average times 0.5, plus your quiz average times 0.2, plus blah, blah, blah. That's how you calculate your average. Same idea, exactly the same idea. Did I tell you the other word for the mean? I don't think I did. If the average age of Grossmont students was 27, right? And I go out and I pick a group of students, I randomly pick students. What's your best guess for their average age? If the average age of all Grossmont students is 27, and I go take a group of 80 Grossmont students, what's your best guess for their average age? 27, right? If the actual average is 27, any randomly selected sample should at least be close to 27. So what's your best guess? What's the expected average age for a group? 27. Does that make sense? Right? Any sample I take, if it's picked randomly, it should represent the population well. So the expected average of a group is equal to the average of the whole thing, right? So another name for mean is